are the x-intercepts. Do you guys remember what other words we use for solutions? Starts with a Z, zeros. It's when y is equal to 0. Solutions, x-intercept, zeros. I'm missing one. Roots. So depending on how they give us the quadratic equation, we need to determine what method we're going to use to solve it. So like I said, before Christmas break, or I'm sorry, winter break, we solved by graphing and we solved by factoring. And today we're going to solve by using square roots. There are 3 steps for us to solve by using square roots. My first step would be to move everything being squared to one side of the equal sign. So it's basically isolating. Let's take off the word move. I don't like that word. We're going to isolate the term being squared. Then step 2, we're going to use the square root of both sides. So square root both sides of the equal sign. And step 3 is to simplify. Simplify. So the reason we do the square root is because the square root is the inverse of something being squared. So if something is squared, the inverse, remember inverse is opposite, is the square root. And if we want to get rid of a square root, then we would square it. All right, let's start our first example. We've got x squared is equal to 9. So we want to identify the term being squared. In this case, my x is the one being squared. So because that x squared is already by itself on one side of the equal sign, then we move on to step 2, which is getting the square root of both sides. So I'm going to get the square root of x squared. And then here we're going to do plus or minus the square root of the other side. These two cancel. We get x. And we end up plus or minus the square root of 9. What is the square root of 9? Square root of 9 is 3. So in this case, we have 2 answers. We have a negative 3 and we have a positive 3. And that's all that means. Now, why is the square root of 9 3? Well, let's look. If we square 3, a positive 3, that means we have 3. Yes. Yes, I am. I'm going to post the notes after and this video as well. Positive 3 squared means we have positive 3 times positive 3, and that gives us a positive 9. Now, if we do the same thing with the negative 3, and we square that negative 3, we've got negative 3 times negative 3, and a negative times a negative is a positive, and that also gives us a positive 9. That is why we have to take into account the positive and the negative of that number. Any questions so far? So this would be my answer. All right, let's move on to example number 2. For example number 2, we have 3x squared is equal to 9. And here we want to identify what is being squared. What is being squared? Is it the 3x or is it just the x? It's just the x. The 3, in order for it to be the 3x, the 3x needs to be in parentheses. For example, if we had, don't write this part down, if we had 3x squared, then we would square both the 3 and the x. But notice how that squared is only attached to that 2. I'm sorry, to that x. So then we need to isolate this. So what would be the first thing to do to get rid of that number that's attached to it? Or what can we do to it? I'm sorry? Right, we want to isolate it, so what do we need to get rid of? Well, not yet that squared, right? The 3, we want to get rid of this 3 that's attached to it. So what's the inverse of multiplying? Dividing. Perfect. So we're going to divide both sides by 3. This gives us 1. So we end up with x squared is equal to 9 divided by 3 is 3. Now that our squared term is isolated, now we go on to the next step, which is to do the what? The square root. So we're going to do the square root of this side and then plus or minus the square root of the other side. Because remember, we need to account for the positive and the negative. These two cancel and we get x is equal to positive or negative square root of 3. Now is 3 a perfect square? No, because you can't get the square root of 3, right? Well, you can, but it's going to be a super long number. So then we keep our answer this way. And remember, we can write it 2 other ways. We can say negative square root of 3 and positive square root of 3. So you'll see it both ways. Any questions so far? All right, another way you'll see this problem or this type of equation is example number 3. We've got x squared plus 5 is equal to 14. Now we want to identify what is being squared and what is being squared. The x, perfect. So what do we need to move? The 5, perfect. And we do the opposite, which is minus 5. We end up with x squared is equal to 9. Now that our x squared is isolated, now what can we do? Square root. So square root of this side, and then plus or minus the square root of the other side. So we end up with x plus or minus the square root of 9. Do we know what the square root of 9 is? Perfect. So x is equal to positive or negative 3. Or negative 3, positive 3. Questions so far? All right, we've got 2 more examples. Example number 4. We have x minus 3 squared equal to 9. All right, what is being squared? Perfect, the x minus 3. Remember, it's everything that's inside that parentheses. So because it's everything that's inside the parentheses, then we know that our squared term is isolated. So then what does that leave us to do? Get it the square root, right? Get the square root of this side plus or minus the square root of this side. These cancel, and we get x minus 3 is equal to positive or negative the square root of 9. And what is the square root of 9? 3. Positive or negative 3. Now notice how my x is still not isolated. We need to create 2 equations. Remember how we did it last semester when we had a plus and a minus? We have to do one equation where my 3 is positive and another equation where my 3 is negative. Did you have a question? No? Okay. All right, so let's go ahead and separate this one. We've got x minus 3 is equal to positive 3. X minus 3 is equal to positive 3. And then we're going to do the negative version. X minus 3 is equal to negative 3. And then we solve for x. I'm going to add 3 to both sides. X is equal to positive 6. Add 3 to both sides. X is equal to 0. Don't be afraid of those zeros. So then my solutions are x is equal to 0 and 6. Any? Yes. Which one? On this one? Well, if you have a negative 3 and you're adding 3, then you go to 0. So if you go backwards, it's 3 minus 3. Kind of like if you owe me $3 and then you pay me $3, then you don't owe me anything. I'm sorry? Mm-hmm. Yes. Uh-huh. So this is a negative and this is the positive. Because remember, we have two answers, the positive 3 and the negative 3. So that's why we have to create two equations. We need to solve it when x is positive 3. I'm sorry, when the equation is positive 3, and then when the equation needs to equal negative 3. And that's how we get our two solutions. Okay, we have one more. Example number 5. Oops. Negative 16 x squared plus 1600 is equal to 0. Now remember, when a function is equal to 0, that's also how we can solve for our solutions. Remember up here, equal to 0. And when we did solving by factoring, we made the equation equal to 0 to solve for our solutions. All right, so this one is the same thing. We need to identify what is being squared. So what is being squared here? Just the x. So that squared only belongs to that x. So let's go ahead and isolate it. What do we need to move first? Then the 1600, right? Because your division is always going to be last. So how do we get rid of that 1600? Perfect. So we're going to subtract 1600 from both sides. And we look at my x squared. It's still not isolated. So what would be my final step? Got to get rid of that negative 16 that's being multiplied. Divide it, right? What's the opposite of multiplication? Division. Don't forget those negatives. That gives us a positive x squared. And that gives us a positive 100. Now there's something interesting when it comes out to a negative, because you can get the square root of a negative number, but we'll talk about that later on. Those are called imaginary numbers. All right, so now that our x squared is isolated, what can we do? Square root. So square root of that cancels that squared, and then plus or minus the square root of 100. We get x is equal to plus or minus 10. Or we can do it as a set, negative 10, positive 10. Any questions? All right, let's go back to our pear deck. Let me print this out right.